In this video of the Soil Slopes and Stream series, we'll talk about mass movements. We care about mass movements because they sculpt landscapes, they link hill slopes to streams, and they pose natural hazards to humans. A mass movement is a mass of soil, rock, and sediment that moves downslope primarily due to the pull of gravity. They take a variety of different forms, for example, as discrete rocks, or as this complex slide that changed its morphology significantly across its flow. Though sometimes the word landslide is used as a catch-all, mass movements actually comprise a group of diverse processes with different names, and they range from slow to fast, wet to dry. We'll use the term mass movement as an umbrella term for these processes here. First, we can think of processes along a spectrum of fast to slow, where this lower right-hand corner represents the slow process of creep. We learned about creep in a prior lecture about soil processes on soil-mantled slopes and how these contribute to hill convexity. Specifically, we spoke about heave processes like tree throw and ice heave that are considered a form of soil creep. However, creep can also refer to the movement of material, either soil or rock debris, en masse. In creep, material moves fastest at the surface, as we learned. In this conceptual diagram, we can see the difference in velocity with depth through the bent rocks. We start with upturned and vertical rocks, and due to the pressures that are active on the rocks, we end up with velocities greater at the surface. There's so much overlying pressure it keeps the rocks at the base strong and immobile, and the sloping surface and overlying material moves the surface down the most. In this case, we see this observable deformation of rock, the bent trees, power lines, and cracked roads and walls. Let's change our perspective of this gradient from fast to slow to include the role of water. Here we can imagine a range of processes that differ in the amount of water, which can saturate soils and fundamentally change the way material moves. As we move across this lower axis, we have processes that involve little water. Fast and dry mass movements are often called falls or slides. And as we move along the upper line, we move across the gradient between slow and fast processes with very wet material. Fast and wet mass movements are called flows. We can now fill in the model here with different processes, most of which you've likely heard of. Somewhat importantly here, not everyone uses these terms the same way. For example, it's not unusual to hear all kinds of combinations of words with respect to mass movements, especially in the news, including mudslides or rock slides. Here, I'll use the terminology that most scientists, though not all, use. But as you'll see in this talk, many mass movements have variable behavior and form that may start in one category and change to another downslope. Importantly, the lines between categories are much more blurred in natural systems that can be easily shown in this conceptual model. Let's start with what's likely the simplest category, rockfalls. Rockfall's the downward motion of rock that topples off a cliff or drops through air. It's extremely rapid, the most rapid mass movement, and it only occurs from very steep faces or cliffs. Rockfalls can be triggered by earthquakes or assisted by the role of water, temperature, ice, and weathering. While rockfall is often considered an isolated event, you can see its legacy in many mountainous systems, and in general, the past is evidence for future and present processes. Meaning if you see evidence of past processes and past rockfall, even if it looks old, you might want to think about where you're standing or where you're camping or where you're building. Landscapes are terrible liars. The clues to their evolution and hazards are all around, but you have to be willing and have the interest and knowledge to interpret them. Follow this link to the video from the National Park Service to learn about how rockfall processes happen in Yosemite and how scientists are communicating and studying hazards. In the next follow-up lecture, we'll continue on with categories of mass movements and their hazards to humans.